Hey guys, how you doing? I'm Ethan, and today I'm going to show you Netlab. Netlab is the network labbing platform that I'm using. If you're old school, you might be using GNS3. Maybe you're using EvenG today, really popular one. Container Lab growing in popularity too. Well, I'm using Netlab. Netlab is I would describe it as YAML-defined labbing. That is, you know your lab needs to be a thing. It's got to have 4 routers and 2 switches, and it's got to have OSPF running and a certain number of VLANs or VRFs or whatever it might be. And normally what would you do? You drag a bunch of objects, fire up the virtual network operating systems, and then stitch everything together, drawing lines between icons and defining interfaces, and then adding IP addresses, and then configuring all the VLANs and VRFs and OSPF and whatever it is you need to do until finally you get to the point where it's like, hooray, the lab is up and running. Netlab takes care of all of that tedious stuff for you so that you can get the lab you need up and running quickly so that you can get quickly to the business of actually doing the lab, which is the point here, right? Okay. So let's take a look over here. Netlab.tools. This is a free tool. It's open source. It's written in Python. It actually uses Container Lab under the hood if you happen to have container-based operating systems. It will use libvirt as a hypervisor if you're not using container-based network operating systems. And it will use Ansible to actually configure things for you. So there's a lot here if you were to dig through the documentation that's going to help you with things I'm not going to show you in this lab, like installation and that kind of stuff. I just wanted to point out that this tool exists and it's free. One key thing that everybody asks about these things, what about the network operating systems themselves? Right, you have to have access to those images, and there's lots of perfectly legal ways you can get access to a whole bunch of different images. If you're looking for the easy button to get started, go look at Arista CEOS, container-based EOS. Arista allows you to download that free of charge with no drama, no logins or anything like that. And it's very Cisco-like. So if you're just trying to figure out how to get started, that's what I recommend you do to get yourself started. So let's jump in here and get a look at Netlab. Okay, so what you're looking at here is a bare metal server that lives in my basement. It has got 8 performance cores. If you're shopping for a CPU because you want to build your own bare metal server for labbing, make sure you look and see not just that it has 16 cores, but that it has a certain number of performance cores, because you'll find performance cores and then efficiency cores. And efficiency cores kind of suck for labbing. You want those performance cores. Those are the ones that you really care about. I'm running some kind of an Intel Xeon. I don't remember the model number offhand. And it has 8 performance cores. And I also have 128 gig of RAM in this box. And I got a couple of SSDs, consumer grade, nothing exotic, but just SSDs as opposed to spinning Rust. And you're looking at my login screen. This is my message of the day that I wrote to remind myself of some of the basics of how to do what I need to do on this machine in case there's gaps in between this and that lab I might be doing at any given time. I don't lab every day, you know. Netlab is installed on here. I also have some of the underpinnings that I need for Netlab here that they walk you through how to install during the installation documentation. Things like getting Ansible installed and so on. It's basically just install packages. I'm running Ubuntu 22.04, long-term support distribution of Ubuntu. I was trying to get Ubuntu 24 going. I had problems. I don't remember what. They made enough annoying changes between 22 and 24 that I was like, I don't want to figure this all out right now. I'll just go with 22 because I've been running lots of servers on 22 and I'm very comfortable with that one. But you can do it on 24 if you're willing to put up with some of the changes that were made to packaging and the way they do SSH and some other fundamental stuff that I was like, really? Okay. All right, so let's get into Netlab. Netlab, as I said earlier, YAML-defined networking. And my YAML files live in a particular folder structure, and that is one of the expectations of Netlab, that you are going to be launching labs from within a particular folder. That's the basic file system hierarchy for Netlab. So in my case, if you actually look at the note I left myself, I'm going to need to change that directory right there. So I'm going to do that, and let's see what I've got in here. Okay, I've got, looks like 3 different labs that I've defined. I got one called 2 routers, one called N for N-STP, and one called OSPF multi-area. N for N, that's my own abbreviation for the N is for Networking podcast. This is a lab that I was beginning to develop to support some N is for Networking podcast content, which is it's a show about networking fundamentals that I do with Holly Metlitsky, if you weren't aware of that one. Good one to subscribe to if you're like working on your CCNA and you're new to networking and want to get into that. Let's actually start with that one. And let's see what files we've got in here. There's a bunch of files in here. Almost none of these I created. The one file I care about is this guy right here, topology.yaml. That's the one I created from scratch to tell Netlab what I want my lab to look like. So let's get into that. Let's walk through it. If you're not familiar with YAML, it is a syntactically specified way to describe a bunch of different attributes. Here we've got a bunch of different attributes that Netlab understands, and all of this is documented where you've got nodes, links, defaults, and then lots of other things dealing with the topology, not all of which you have to invoke, but here's the documentation that begins to explain to you how your YAML file needs to be specified and how Netlab is going to parse that data. So we've got a module here, the VLAN module, that tells Netlab, hey, we're going to be doing VLAN stuff in this particular lab, and it will be expecting some VLAN directives later on in my topology file. Provider, CLab, as in container lab. What's the platform I'm going to instantiate my network operating system images in? CLab is container lab in this case. Tools. Edge Shark. And if you're going Shark, like Wireshark, yeah, kinda. Edge Shark is a tool that will allow me to run Wireshark against any of the interfaces that show up in this lab from a remote machine. It's pretty cool. And Edge Shark is supported here, and there's documentation from Netlab that explains how to get Edge Shark installed and so on. And we'll show you what it looks like a bit later here. I got some more defaults. I've got other VLANs. I'm not going to parse this out line by line, but more I'm just trying to give you the high level of, hey, I'm defining a lab in this file. As long as I get this file right in a format that Netlab can understand, then my lab is going to be started up by Netlab without me doing a whole lot of definition of things. I've got a VLAN called core that we've defined here. I've got 6 nodes. I've got 3 Linux hosts, Andy, Colin, and Dave. Leave in the comments if you get the Andy, Colin, Dave reference. And then these other hosts, SW1, 2, and 3, are going to be a default image. And what's my default device image? It's EOS. So that's as in Arista EOS. Now I've got a section here called links, and then what I'm doing with this link section is defining how each of these nodes that I've defined up here are interconnected. I don't want to go in and draw lines between icons and say this interface to this interface and then, do a bunch of other stuff afterwards. I just want Netlab to stand that up for me and have all of that work done once the lab comes up. And that's what this links section accomplishes for me. So I've got switch 1 to switch 2 using interface index 1 here, which I don't have to define, by the way. I don't have to tell it what. I could just say, Netlab, I want switch 1 and switch 2 to have an interconnection, and I don't care how you connect them. Just do it, and it'll pick interfaces itself. But if you want to really be controlling, you can say what specific interface index you want to use. And in this case, that'll come up with ET1, as in Ethernet 1, on each of those switches. If you're trying to map what does IF index mean here, that's what it'll translate to. And I want those interfaces to be in the VLAN access called core, which you remember we defined earlier in our YAML file. And there's a whole bunch more different links that we've defined here. And what this will end up looking like, I'll draw this out for you. This will end up looking like a triangle where I've got switch 1, switch 2, interconnected, switch 3, and then I'll have, I think I set it up like this, where I've got my Linux hosts hanging off here. Andy, Colin, and Dave. There we go. That's what this topology is actually going to look like. If I remember exactly how I defined all the different links in there, I think that I got that right. It's very similar to that, if it's not exactly that. But this is the intention of the lab. It's a spanning tree lab that I'm in the middle of. I haven't actually finalized it yet, but that's what that all that YAML is going to result in. Okay. So I've got this topology.yaml file. Now what? I want the lab to start. Okay, Netlab up. Now magic is happening. Okay, Netlab is parsing my config file. It's firing up all of these different nodes into Container Lab because I'm running Container EOS, CEOS from Arista. So Container Lab is my provider that can handle those images. And now Ansible is running once those images come up to configure the switches in the way that I need them configured, which is very simple. There's just some interface interconnects. There's going to be some descriptions that we're going to see, and we are going to see the hosts plugged into certain interfaces here. So you're seeing all of this happening, a bunch of checks going through that you don't have to care about particularly in much detail unless there's an error. There's various errors that might come up as you're running Netlab if something's not quite right. But we're getting to the end of the Netlab boot process now. We're just about done, and there's 2 lines I want to point out to you. 1, success, lab device is configured. Okay, that means exactly what it sounds like it means. We have these 6 devices up above Andy, Colin, Dave, switch 1, 2, and 3, up and running and configured. There's a configuration on them. The second line I want to point out to you is external tools started. Well, what are the external tools? Remember that I mentioned EdgeShark. EdgeShark is the tool running on my lab server that enables me to run Wireshark from a remote machine and then capture lab traffic. Okay, I'll show it to you. I know you want to see it. What's it look like? I want to see. I see a URL. Show it to me, Banks. All right, I'll show it to you. Open a tab. And it might, depending on what boot state we're in, it may or may not come up yet. Okay, yeah, not yet. Let's hit the refresh button. Bang, there it is. Okay, so now we're looking at EdgeShark interface. I HTTP'd from my browser on my local Mac here down into the lab, and it's showing me all the different interfaces that are being exposed that are supported here. And if you look at this, it's a little cryptic, it's a little esoteric, right? And you're like, that's ugly. What am I looking at? Don't worry about every single thing here that's been exposed. If you care about something like on switch 1, which you can infer that was one of the host names from our lab, right? In switch 1, I've got Ethernet 1, Ethernet 11, and then some other Ethernet interfaces. I could sniff one of those. That's a lab. That's a video lab for a different day. I just want to kind of expose to you that exists. Yes, you can do Wireshark packet captures with labs, which any lab nerd cares about. Now I've got my lab up and running. If I do a Netlab status, it'll give me some more detail about all the nodes that are running in my lab. Oh, okay, there's Andy, Colin, and Dave. They're all running Linux. They got some management IPs there, and switch 1, 2, and 3, they're all running EOS, and I got management IPs there. EdgeShark as a tool is running. Cool. How do I get to them? Well, one way you can do Netlab connect, and I can put in the host name. So let's put in SW1. This actually, SW1 type like this isn't going to work. I just want to demonstrate that Netlab cares about case. The host names are case sensitive. There it is. It works. It's connected for me on SSH port 22. There I am at a prompt. And if I do a show version, what do we got here? Okay, what we expect, CEOS lab from Arista and some other information. If I do a show run to show the running configuration that has been put into this switch, we're going to see a lot of stuff that I didn't type in. Things like, this username admin. I didn't do that. Netlab took care of that. Part of the Ansible package that it pushed here. Things like hostname and all these statements. I didn't put any of those in there. Netlab just did that for me. VLAN 1000 name core. Well, where did we say name was core? Well, that was in the YAML file, topology.yaml file, remember? I could have named it whatever I wanted. Other things you might be curious about, like, well, where did it come up with 192.168.121 network to be putting these management interfaces in? It just picked that. Netlab just chose that block for me because I don't care. I don't want to have to care. Now, if you do care, it's important to you what IP address range that these different IPs are in. You can totally do that. You can define those if you want within Netlab. It's just, for the most part, I don't care about those sorts of details because that's not the kind of thing that I'm labbing up. So it doesn't matter to me. We've got some other interfaces here in VLAN 1000. Let's do a show IP interface brief. You'll see that I've got a VLAN 1000 interface into 172.16.04/24. Again, where did it come up with that /24 net block for VLAN 1000? Netlab made it up, and I'm cool with that. I don't want to think about it. Doesn't matter to me. All right, so, and just to quickly demonstrate that these switches are talking to each other, I'll do a show LLDP neighbors, and you can see that I'm on switch 1, and it sees switch 2 and switch 3 hanging off these other ports. And remember what our lab looks like here. Switch 1, switch 2, switch 3 in that triangle, and so we're seeing what we expect to see, that those switches can see each other off of various ports. Okay, that's enough for this lab. Let me exit out of this. I'm just trying to show you the real basics here. So let's go into another lab. If I review, we've also got OSPF multi-area as a lab. That's also interesting, an interesting one to show. So let me go in there, and now I want you to remember that other lab, I never shut it down. It's still running, right? Okay, that actually is going to matter in a minute, but well, foreshadowing. All right, let's look at the OSPF multi-area topology.yaml file, because that's the name of the file you're going to have in every folder that you're going to create for a particular lab. You're going to have a topology.yml. That's what Netlab is looking for. I'm pretty sure you can build other names and tell it when you say Netlab up what YAML you want it to look at. I think I'd have to go look at documentation. I don't remember for sure. This is a very different lab. The other one was running Arista CEOS. This lab is running iOS V, which is not a container-based network operating system. This is going to run in libvirt as the hypervisor, and so things are just going to be different when you fire this thing up, and I'll show it to you in just a minute here. But just quickly walking through, we've got device defaults of iOS V instead of CEOS that we were looking at in the last one. We've got a bunch of links defined. Notice I am saying core 1, core 2, et cetera, et cetera, et cetera, but I didn't get into like IF index. I'm just saying, hey, Netlab, core 1 and core 2 need to be linked together. Whatever interfaces you need to use, do that. I don't care. Doesn't matter to me. And then I've got, so I've ended up with 4 core switches, and then I've got some other device I'm calling Edge 1, 2, 3, and 4. So I've got edge switches with different OSPF. So let me show you what this lab is going to look like, just so you got a quick idea in your head. This one is going to look like this. Sure, we'll stick with blue. Why not? I like blue. Blue's a great color. So I've got core switch 1, 2, 3, and 4. They are interconnected like this based on what I have defined in my topology YAML links. And then hanging off of that, let's use a different color because colors are fun. I've got an edge 1, 2, 3, and 4. Wow, that's terrible. Let's do better. Let's do a little better. Go away. Go away. Thank you. Edge 4, and then they're interconnected like that. And then my OSPF areas look like this. I've got that's area 0. That's my backbone area, and then I've got these other outlying areas here. You think you see where we're going? You get it. You know what's happening here. That's going to be area. That is deplorable handwriting. Area 1, area 2, area 3, and area 4. So you get the big idea of what this lab's going to be. Topologically with OSPF, things I was going to show. I'm still working, again, it's another lab I'm still working on here. You get the sense of it. That is what this YAML file is defining for us and what we're telling Netlab to build with both the links, the OSPF areas that various of the links are placed in, the fact that we are running the OSPF module. Like, wait, the module and the other one was at the top, the module statement. Does the order matter? It doesn't seem to. It is hierarchical, but not top to bottom ordered in these topology.yaml files. So I've got a default area here, area 0. So if I'm kicking off OSPF on a particular link, but didn't define it, then that's going to be in the backbone area. And okay, you get the idea. We got all our nodes defined, and that's all we need. So now, remember the foreshadowing thing? Okay, so now if I do a Netlab up, this isn't going to work. Oh no, it didn't work. What happened? Well, what happened is I've already got a lab instance called default running in this particular directory. Whoops, I never did clean up the previous lab. Okay, so it really wants me to shut the other lab down. Can I run more than one lab at a time on a Netlab server? I don't know. That is something I haven't actually tried to do before. I just know it hasn't allowed me to do that, so I don't know if there's a way I can make that happen or not. In theory, if I've got the horsepower, maybe, but it could be because of the hypervisor layers are underneath. That's not realistic. That's not a thing that can be done. I don't really know. I haven't dug in. So let me go back into the folder where I had launched this lab, and so that you see a bunch of statements here about cleaning up and so on. I just want to make very sure that it cleans up after itself. So if I use Netlab up, what do you think I'm going to use to shut the lab down? Netlab down. There you go. So Netlab down. Okay, everything's been cleaned up. And if I do a Netlab status, just to double check where we're at, no labs are running. Okay, let's go here and do Netlab up again. We're launching, and this looks different. Hey, starting libvirt nodes, and a lot of what's going through here for status messages as the lab launches looks a bit different than what we saw with Container Lab. And again, what we're building is going to look like... I'm sorry, that is messy. It's my version of a whiteboard, so I can at least get you a quick and dirty picture of of what's happening here, and you can kind of map that into your head. So it takes a little longer for images to fire up in the libvirt environment. And now that once the images come up, then you're needing Ansible to do the configuration that you specified. In our case, the big thing we specified in the topology YAML is OSPF. And so the images have to launch, and then we've got to get base configuration on them. We don't. Netlab will do that for us again. So that's happening. And you can see this. It's been trying to launch. It's been connecting. Okay, now it can get SSH connections into these images, and we're seeing the playbooks get pushed. Variety of messages, warnings, various things went by, nothing that seemed critical. We have our success message. I don't have the second success message about Edge Shark because that was not part of my topology YAML. I didn't happen to have Edge Shark kicked off. I didn't tell Netlab to do that for this particular lab, but we're there with the lab launched as configured. And if I say Netlab status, yeah, exactly what we expect. We've got 8 iOS V images up and running with a bunch of management IPs, and they're all doing the thing. All right, so now if I do Netlab connect, let's look at core 1 just before. Yeah, there we go. We're connected. And just, again, to remind you of what we got, we're here. We're on this Core 1 switch. So I should have 4 OSPF peers. I should have Edge 1 in Area 1, and then I should have a connection to Core 2, Core 3, and Core 4. So I should have a total of 4 OSPF neighbors if I did all the things right. Call the diagram my intention. And so did we fulfill our intent with the way we defined the lab? And by we, I mean me. I'm sorry, I didn't mean to loop you into that. It's all my responsibility, honestly, what just happened there. Show IP, I can't type. Show IP OSPF neighbors. Okay, indeed, we do have full. We have 4 OSPF neighbors as expected. I don't have the neighbor IDs off the top of my head. I could have defined those if I'd wanted to in the topology YAML, if that was important to me. So let's just look at the OSPF database here and see if we've got area 0 and area 1 represented. Yeah, we do. Okay, router link states in area 0. And then router link states in area 1. Fewer of them. That all makes sense. And one of them is 10005 as the area ID of that router. So let's open another tab. And if I go to and I say Netlab connect to Edge 1 again, so I'm connecting to this device here. Yeah, okay, that is the IP address that ended up being selected as the router ID for this OSPF device. So that is the one that we were expecting to see. Looking at the router link states for area 1, so that all makes sense. And here I should have 1 OSPF neighbor, right, going to core 1. All right, all of that just to prove that the lab came up as expected. We used YAML to define the topology. And if I take you through some of the documentation here, my goodness, there's a lot of different things that you can configure within Netlab. A BFD is supported, BGP, DHCP, EIGRP, etc. These are all different modules that you can use to define your lab. And so if you've got a complex lab environment and you're willing to put the time into standing this up via a YAML file, which might take you a bit of time. In fact, I would say the YAML configuration for me has been the most challenging part of Netlab. Not because it's hard, because it isn't hard, it's easy, but there is syntax, and syntax matters with YAML. You got to get your spaces right, and you got to get your hyphens right, and white space matters here. And if you get that wrong, then either the YAML file won't be valid, it'll be invalid. So I'm actually using a linter. If you look on packetpushers.net, I wrote about using a linter in VI as my editor to write my topology YAML file. Although there's lots of ways you can figure out how to validate your YAML. But that's helped me a bit. Like, that's wrong. That's wrong. And the linter points out where I do bad things with my YAML. But between that and then understanding what Netlab is looking for in those YAML files so that I define my links correctly and that I define my OSPF correctly and so on, it takes time and reading. Again, not hard, but you will invest some time to understand how these different modules work so that you can define them correctly within YAML. Lots going on there. Oh, so bottom line, I think Netlab is great. I do. I really am a big fan of Netlab. And I haven't even touched the more complex modules. I just wanted a platform that would allow me to stand my labs up quickly and cleanly and not have to fight with configuration or spend 3 hours building something. And I'm still fairly new to Netlab in the sense that I haven't built tons and tons of YAML files. And so it's not like it's automatic for my brain yet, but where I'm headed here and what seems to be working out really well is that as I get more competent with it and it becomes more natural, it's easier and easier to build these topology.yaml files to define my lab, and getting them started is just an easy thing. So again, this was netlab.tools is where you want to go. This is all put out by Ivan Pepelnyak of ipspace.net. I know he's done most of the coding, and I believe he works with some other folks too that help with creating these new modules and supporting different devices and so on. I mentioned Arista and a Cisco image, but there's lots and lots of other images that Netlab supports, assuming you have access to those images. And it's a great tool. It's a great tool. So go to netlab.tools, visit ipspace.net. Let Yvonne know you really appreciate this if you try out Netlab and like it as much as I do.